Hello, my name is Heikki Mustonen and I'm the Managing Director in Adwatec Oy. We design and manufacture water and liquid cooling systems for power electronics like drives, converters, rectifiers and batteries. In today's presentation I will discuss the ways to reduce the equipment failure risks on board the vessel when using water cooling solutions. Marine systems use liquid or water cooling for space reasons. Cooling in general and water cooling specifically pose risks for the energy system. A leakage and the lack of cooling because of that may lead to partial or total failure of the vessel. You can imagine the following situation. A service vessel captain is maneuvering the vessel next to the oil drilling rig in rough seas. Then suddenly the engine stops. The cooling liquid has leaked out and the engines are red hot. The vessel is uncontrollable next to an oil drilling rig. This is not acceptable, but this is something that has actually happened because of the leakage. The liquid in the liquid cooling system has a very important task to remove the heat away from the heat source. Therefore, the leakage of the liquid is not acceptable or desired. There are multiple ways to minimize or completely eliminate the risk of the leakage. The main ways that I present today are build to last, reduce the number of potential leak spots, and standardize the cooling solution. The cooling system may be built to last. In practice, this means that the system will be engineered and built so well and so rugged that it will work no matter what. A very good example of this kind of implementations are the military applications. The only issue in this kind of approach is the cost. Over-engineering and bomb-proof material selection will increase the cost dramatically. So this alternative is applicable for extreme cases only. For commercial high-volume applications, this is not viable. There are basically two physical alternatives how the leakage may happen. One, the component connection interfaces may be poorly assembled or may have weak elements like sealing. And two, the components may be weak due to bad welding or wrong materials may have been used. When it comes to component connection interfaces, there are again two remedies to minimize the risk. First, less connections means less risk. But how to reduce the number of components and thus connections that are used? In practice, the way to do this is to use components that integrate multiple system functions to one element in the design. A very good example of this is a manifold including sensors, three-way wall structure, side glass and piping connections. Typically, a manifold solution is also smaller in dimensions. Well, connections can't be completely avoided. Therefore, the installation and the assembly work should be done and the cooling system tested in a professional way. If this is done in a factory environment, the work and testing can be done in line with high quality standards. A factory-level testing will also bring up the welding quality issues at relatively early stage, so the quality issues don't have to be faced later on board the vessel. When it comes to the material selection, it is crucial to have the know-how of what can be used and what not. There are material and cooling experts in many companies, but for sure the best understanding of this is among the cooling system manufacturers, as we deal with this every day. Here the very important issue is that the complete cooling setup is well known. What is to be cooled, what is the coolant used, and what materials are used in, for example, drives application cooling circuit. Once this is clear, the cooling system manufacturers know and are able to select the correct materials to be used. There is limited amount of space available in the ship. Our experience is that the cooling piece is one of the last items that will be dealt with. And because there's little space left at that point, the liquid-cooled systems are often tailor-made. Therefore, the requirements for the cooling may be extraordinary and often unique. Uniqueness or one-off designs mean risk. There are two approaches to limit the risk here. The best approach would be to consider the liquid cooling system design at an early stage in the engineering process. This way, standard cooling solutions available in the marketplace could be used and fitted to designs as such. Standard cooling systems are manufactured in high volumes, are field-proven, and come often with type approvals like DNV. If there is not enough space available for a standard cooling unit, another good approach is to use cooling solutions that are made of standardized modules. The modules can be used decentralized in a flexible manner to implement the cooling system, but with the benefits of proven, tested, standardized products. This way, the system could be fitted to meet the height and width requirements and possibly decentralized and not as one object only. Even the best solutions may not always work, so prepare for the worst. A leakage monitoring system might be a solution. No matter where there is a leakage, the monitoring system will give an early alarm and the power electronics can be switched off before major failure. Water cooling is sometimes considered risky, but with correct measures it will work in a very reliable way. The less is more. Reducing the number of potential leak spots means less connection points. Prefer manifold block designs. The factory assembly and system testing possibilities ensure the high quality of the cooling solution. And finally, marine cooling solution should be considered at an early stage of the project. This way, standardized solutions can be used instead of tailor-made one-off creations. Thank you for listening and keep it cool.